This video is about the effect of pH on enzyme activity. So our title today is Enzymes and pH. By the end of this lesson we should be able to state the optimum pH for the activity of amylase, pepsin and lipase, and we should be able to describe how denaturing prevents enzymes from performing their function, using diagrams to help your description. So we should write our notes in the Cornell note-taking style, with our objectives on the left, matching up on the right with our notes, which are answers to those objectives. Finally, you'll write a summary in your own words of the lesson. So the important part of an enzyme is the active site. The substrate fits into that active site, similarly to how a key fits into a lock. However, when an enzyme becomes denatured, the enzyme changes shape, which can mean the active site is no longer accessible to the substrate because of that change in shape. So we'll take a look at amylase. Amylase has an optimum pH of 6.8. That means if it becomes too alkaline, going up to pH 14, the enzyme will change shape. Similarly, if it becomes too acid and goes down to pH 0, the enzyme will again change shape. This means the substrate, in this case starch, will no longer fit into the active site of the enzyme. When that happens, amylase is no longer able to break down starch into simpler sugars. We can see from the graph the optimum pH is represented by the peak of that graph. In this case, the peak being at pH 6.8. Pepsin has an optimum pH of 1.7. That means moving from 1.7 up to neutral, which is 7, the pepsin will denature. So even in plain water, pepsin will become denatured. It keeps its shape only in acidic pH. Again, because it becomes denatured, the substrate no longer fits into the active site, and so pepsin will no longer be able to break the protein down into amino acids. Here we have our graph again, showing that the optimum pH, the peak of the graph, is around 1.7. Lipase. This has an optimum pH of 8. In this case, if the pH goes above 8, the enzyme becomes denatured, and if it goes below 8, the enzyme can become denatured. Again, this means the substrate will no longer fit into the enzyme to its active site, and so the enzyme can no longer break the lipid down into the 3 fatty acid chains and the glycerol head. Here we see the graph showing that the peak for optimum pH is at pH 8.